Welcome back, everybody. So this is the new video to follow up on the two previous one. So now we've seen why connectivity is important, why it's not plug and play, what is the more theoretical framework for connectivity, and how this framework operates in reality, what issues comes up using that framework. And now the question that arises from the last two videos was then, because there's multiple ways to do connectivity, who should do the connectivity? Um, and really, for who should do connectivity, there are several options. So it could be the MES vendor, the machine vendor. You could use a standard. You could go a DIY approach, go through a system integrator, or the new kid on the block, use AI. I'm gonna evaluate them across three different axes. So the first one is machine semantics, and I really want to focus on semantics here and not protocol, not format, not information model, because we established in the previous video that this is really where it hurts in the end. So this is where it's worth paying attention to. The other one is MES semantics, because there's not only one semantics, there's actually two you need to understand. And the last one is kind of a newer topic. It's reusability and maintainability. So it's how much you can leverage other installations you've done and reuse what you've learned. And because the machine and the MES over time would get updated, it's how much it would be maintainable going through a way or another. So the first one is MES. As we discussed on the machine semantics, it doesn't have access to the source code. So you will need to rely on samples, documentation, technical contact, equipment partnership, maybe experience also, to tap into this the machine semantics. So this one is really not solved. The MES semantic, though, you do have access to the source code. So this one is solved. And as for the reusability and maintainability, this one, if you do it for a machine and reuse it across multiple lines, sites, customers, then you would be able to reuse it and maintain it over time as the MES vendor. The machine vendor, if you go that route, then it's the other way around from the MES route. So the machine vendor would have access to the machine semantics, but it won't have access to the MES semantics. So again, sample, documentation, technical contact, partnerships, experience, they will need to rely on them to really tap into the MES semantics. Reusability and maintainability, well, pretty much the same as MES. If they do it across multiple customers for the same MES, then they will be able to reuse it, easier to maintain. So that's also give it a go on that front. Now standard, this is an interesting one, because the face value is, you would think, yeah, it would bridge, it will enforce semantics on both the machine and the MES, right? Well, the standards, they are useful. I mean, I love standard, but do they solve everything? No. I mean, if they were to solve everything, I would not be able to work anymore, and I like to work. So this is not solving everything. So I'm just gonna elaborate maybe a little bit about the specific standard in our industry. I think it's worth it at that point. Give a bit of history. So there are four major standards. The first two one are SMIMA and Hermes. Those are more horizontal focus, so more machine to machine and less machine to upper level system. So I'm not gonna focus on those one for this example, because it is machine to MES in the end. So the first standard that was implemented is CAMX. CAMX, it was a standard, in my opinion, ahead of its time. One of its issues is that it required the implementation of a protocol based on SOAP, and it requires a lot of technical knowledge to implement, so the adoption got difficult because of it. On the format, it was using XML, so XML was pretty standard at that time. Um, but it's really about the information model that CAMX got hurt, because you could have as much extension and put whatever you want in extension. So that ultimately made the semantics very hard and pretty much custom to every machine vendor. So it didn't really standardize the industry, so was not really adopted. Also a disadvantage, not really covered, but it was not bidirectional CAMX, which was also a disadvantage. The other standard is CFX. So CFX it's meant to address what CAMX missed. So it's based on AMQP, and it has a great implementation. It's pretty easy to implement with the library provided. For the format, it's using JSON, which is very standard. The interesting part for me is the information model. In CFX, the information model is very rigid. You cannot implement new field, new events. You have to go through the CFX committee for any change you want to do. So the information is very complete. So you can take, oh, if the information model is very complete, is the semantics very complete? Unfortunately, it is not. I'll just come back to the fail example, which I had before, which actually come up from a CFX integration we did. So the machine did output fail as the barcode, and this is something we had to manage because CFX doesn't enforce what to do where there's a barcode failure. This is just one of the situations. If CFX had to impose what to do on every single situation, the standard would make thousands of pages, and it would be just to be able to implement it and be able to enforce the implementation. The qualification would take forever. It would cost a fortune. I mean, it's just not viable to have all of the semantics in the standard. So bottom line is the standard, it's kind of a percentage. So you would get, I don't know, 80, 90% of the semantics with the standard, but you still have like a 10, 20% to figure out on your own. Is it reusable and maintainable? Yes. Of course, that's one of the biggest advantage of standard. It's very interoperable. You can use it across different MES and machine. That's the whole point. Now, the next one, another very interesting one, it's the DIY approach. So that's like a good idea, because who's better place to know the machine you have on your shop floor and how you use it? You're the better place to know that. You also, from the MES use, maybe you build it yourself, but even if you didn't build it yourself, you know what you want to get out of it. So you have a great working knowledge. So these ones, honestly, are pretty much solved, which make them really compelling. Of course, there might be things you're unsure about, and you still need like a technical contact to answer some of your question or partnership. But because you are using the machine and the MES, you already pretty much have, as the end user, some partnership or some collaboration with the MES and machine vendors. So that's a big advantage going the DIY route. But still, I mean, you would need some minor adjustments. So there's still a percentage of it where you won't be able to solve on your own. And as for reusability and maintainability, this is where it hurts, in my opinion, because you would have to figure out all the edge cases yourself. You have to figure out when a machine MES update, you have to update it yourself. And at the end of the day, I mean, you're probably not a software company. You're building PCBs. So if you go that route, at some point, you'll almost become a software development company. So this is maybe not the approach you want to go to. So this one gets a no on my book. The system integrator route. This one is very interesting because it would really depend on how much the system integrator know the machine and the MES. So this one, I'll just put the question marks, because it could be very good, it could be very bad. Really depend on who you're working with. And as for reusability, maintainability, there's a decent chance that integration has been done somewhere else before or another plant. So you would get some benefits of that reusability, maintainability. But because it's instead of being one to many or many to one, it's many to many, that will still be more custom every time. So there's only like a percentage of case you would get out of the system integrator. And now the last one, the AI route. So this is also very interesting, new kid on the block, um, very promising. Honestly, if you give it documentation sample on both the machine and MES side, the AI will absolutely, at this day, give you a working solution to push your data to your MES. 100% it will work. The only thing with AI is that it doesn't know the machine semantics. In the end, it doesn't have access to the source code of the machine. It doesn't have access to the source code of the MES. Well, it didn't hopefully train on it because AI, they train on a lot of public data, and this is all proprietary data that is not accessible, and hopefully there was no data leak on both the machine and MES side, so AI won't have access to it. In the end, to have a proper integration, you will need to constantly feed it, have question, reach out to a technical contact, feed it back to the AI. So in the end, it doesn't really solve by itself the semantics layer on neither the machine or the MES side. On reusability, maintainability, though, it is so quick to do an update once you feed it data. Pretty good at this point that honestly, I would give it a pass for reusability and maintainability just because it can produce something so easy. So as you can see, these are your options for who can do the connectivity. There is no silver bullet. Everyone has their own advantage and disadvantage. Um, so for us at Cogiscan, we mostly fall into the MES category. We also do some other part, but most of what we do is connecting machine to our own domain-specific TTC. And where it hurts the most is the machine semantics. This is something we solve because we have 25 plus years of experience in the industry. We've built meaningful partnerships with machine vendors. We have a lot of customers where we encounter a lot of edge cases. So this is how we do solve semantics, I believe, better than somebody who don't have this type of experience. In the end, there's no silver bullet. As I said, you really have to look at your own situation and decide what's the best in your case to do. So I hope you learned something. If you disagree, please put it in the comment. If you agree, put it in the comment also. Engagement is engagement. So I hope you have a way to do better connectivity on your factory and you don't end up yelling board out every time a board comes out of a machine. Bye everyone.